In this section, we're going to look at adding and subtracting rational functions. When you add or subtract a fraction, you have to make sure that the denominators match. For this first video, we're going to look at functions or expressions that will be easy to combine because the denominators match or almost match. In this first example, we see that our second denominator is a -2 minus x. If we were to factor out a -1, we would have 2 plus x inside. This is very similar to our other denominator. Notice that the only difference is that the order is now opposite. So we know that this is equivalent to -x plus 2. I can bring that negative sign up and replace the positive sign with it. And so now my function is equal to 7x over x plus 2 minus 3 over x plus 2. And now our denominators match, and we can combine our numerators over one matching denominator. 7x minus 3 over x plus 2. Let's look at the next example. We need to perform the indicated operations, simplify when possible, and if I look at all these three denominators, I see that they all match. This is nice because I can rewrite this over one denominator, 3m squared n squared, and combine the numerators. So 8 plus 5 minus 2. Rewriting that, I get 8 plus 5 is 13, minus 2 is 11. So I have 11 over 3m squared n squared. In this next example, we have 5 minus 4x over x squared minus 6x minus 7 plus 5x minus 4 over x squared minus 6x minus 7. Notice the denominators match. We can rewrite it with one denominator, x squared minus 6x minus 7, and rewrite the numerator, 5 minus 4x plus 5x minus 4. We can combine like terms. 5 minus 4 is 1. And -4x plus 5x is just x, all over x squared minus 6x minus 7. If we wanted to check for one more thing, we could factor the denominator just to see if it would factor. So I have 1 plus x. We could also think of this as x plus 1. Either way is okay. And in the denominator, let's see if we can factor. We would have an x and an x for our first term in each binomial. We would need a 1 and a 7 to get a 7 as the final number in the trinomial. And we need our bigger number to be negative and our smaller number to be positive. This actually does reduce further. Notice that the factor or terms in the numerator, they're identical to the one in the denominator, so I can reduce that out. I'm glad we checked because now I have 1 over x minus 7. Let's take a look at this last one. We have 3a minus 2 over a squared minus 25 minus the other fraction 4a minus 7 over a squared minus 25. I'm going to factor the denominator most likely to see if there's anything that divides out. But first, I'm just going to rewrite it with one common denominator, a squared minus 25. In the numerator, I'll have 3a minus 2. Now this is a very important thing to remember. If you have a subtraction here and there's more than one term after it, you have to make sure you distribute that negative to everything in the second fraction's numerator. So the best way for me to remember that is to use grouping symbols. So now I have 3a minus 2, distribute the negative, minus 4a plus 7, all over a squared minus 25. I'm going to rewrite that up here, combining the like terms. I have a 3a and a negative 4a. I have a negative 2 and a positive 7. This will give me negative a plus 5 all over a squared minus 25. If I rearrange the order here, that's not going to be helpful. But if I were to factor out a negative, I would be left with positive a minus 5. If I factor the denominator, I will have an a plus 5 and an a minus 5, because this is a difference of squares. And from there, I can see that one of my factors will indeed reduce. So my final answer will have an a minus 5 divided out to give me negative 1 over a plus 5.